Every one of us here was born a tiny little node in the graph that is our family. I bet your parents never told you that, did they? But it's true. You can see for yourself. Here's the graph. Who here was born in Spain? Okay. Oh, lots of hands. All right, well, there you are. Other countries in Europe, just shout it out. Denmark. Okay. There you are. Anybody born in North America? Yeah. Okay, nice. I got you one way or another. Any other countries? There you are too. See, I wouldn't leave anyone out. I wouldn't think of it. Now, where was I born? Thanks for asking. I was actually born all over there, in the Far East, Vietnam. So, up at the top here, we have our ancestor. This is the MRCA, the most recent common ancestor. So we're all connected. It's almost like this is just a big family reunion here. And except there's beer and swag and paella. That was great. But this being a React conference, I'm sure you're all noticing that this looks a little bit like the React component tree as well. So you're right. So we have this in common, yet we're all special and unique. And the reason for that is, and I'll spare you the details, but our ancestor passed down their genetic material from generation to generation, all the way down to where we are now. And that's what we call some serious prop drilling. Now, when we talk about family history, we love to lean on this metaphor of a tree, especially when we talk about genealogy, which is the study of family lineage. Now, this type of thinking is rooted in biblical times, but it was further developed in medieval Europe. So, trees branch upwards and outwards, right? So from a single ancestor, the tree represents growth and divergence over generations. The ancestor can have children, and those children can have children, of course. Now, the ancestor, as you probably know, was not the first person or first human in the tree. So conveniently enough, those trees can actually have their own roots, which is useful in representing even further back ancestors. So what you end up with is a trunk, a sort of main line of lineage or ancestry, which historically speaking tended to fit that mental model of hierarchical societies that were always focused on patrilineal heritage. However, we are modern thinkers, and we speak in computer science terminology. And for us, of course, a tree can't truly be considered a tree, because we know that in tree data structures, graph nodes, they only have one single parent. So instead, we represent family history as a graph, or a network of individuals, and also connections between them, so edges. This is also referred to as a DAG, or a directed acyclic graph. Now, it's directed because the flow always goes from ancestors to descendants, from parents to children. So, for example, that includes things like genes, inheritance, and family names. And it's acyclic because you just can't have any cycles or loops, right? A person can never be their own ancestor. So that concludes the history portion and the graph theory of this talk. But I just wanted to convey this information to you now so that it'll feel a little bit familiar as we explore the topic of, can web developers relate to genealogy? Hi, everyone. Hola, Alicante. My name is Kevin Mays. I'm a software engineer from the United States. I've been living and working in Malaga, Spain for the last 2 years. During that time, I've worked for companies like Stately, building developer tooling like Stately Studio based on the XState library. Eric told us about that. That is the open source TypeScript library for state machines. Also worked at Lab 49, which is focused, it's an international consultancy focused on fintech apps for web and mobile. And I recently started working at a new company, brand new company, called Blue Folders, which is a venture studio. And what we do is we work closely with design partners or experts in domains, and we spin up new companies based on agentic workflows in industries that are really ripe for disruption. I want to tell you a story about a box. About 10 years ago, I was living in New York City, and my father came to visit me, and he said, "Hey, Kev, I've got this box of genealogy that I found cleaning out my basement. Lots of great stuff there. I used to do this stuff back in the 80s, 1980s. We've got the MAES or Moss family going back to the 1600s. We've got your grandmother's Heinz family going back to Germany. We've got your mother's Jewish ancestors going back to Bessarabia, which is Moldova today. Really great, fun things here. I'm not going to do anything with it, so here you go, it's yours." So when I looked at this box, I felt like I had discovered treasure. It smelled like decades-old paper, but there were pedigree charts and census records and birth certificates, baptism records, marriage documents, obituaries, snail mail, everything. And so many black and white photos. From a time when having your photo taken was so special, you got all dressed up to do it. And it was definitely not something you took of yourself. Now, seeing all of my dad's handwriting and his notes and annotations made me really appreciate the amount of time and effort he put into collecting all of this information. That box was like a time capsule within a time capsule, and now it was mine. So I got to work digitizing. Now, as a Mac user, I happen to use a software called Mac Family Tree, not because it's the most popular, but because it's got amazing UX and design, and it's got mobile and cloud sync, and it's really got the best design on the market. And as a developer, entering data into a beautiful program makes a hobby that much more enjoyable. Now, I know not everyone uses Mac, so in fact, I'd say the majority of family historians are probably on Windows. So in that case, there are alternatives, such as Roots Magic or Family Tree Maker for cross-platform. But after years of late nights, searching website databases, interviewing family members, my family tree has grown to about 1,600 people and 600 families. Now, branches of those families range from North America, South America, to Europe, as I said, to the Middle East and Australia. And it even includes Spanish ancestry going back 16 generations. Now, funny enough, you notice I didn't mention anything about Southeast Asia. Well, that's simply because I was adopted to the US. So out of all these 1,600 people, I'm actually only genetically related to 2 of them, my 2 kids. But that never stopped me from going all in on this family search. After all, that was the box I was given. Now, today, there are countless online resources and platforms for genealogy. The largest is FamilySearch.org, a nonprofit operated by the Church of Jesus Christ of Latter-day Saints. Due to their strong religious dedication, they provide Family Search for free. It has billions of searchable names and images collected by volunteers all over the world. Did you know that here in Spain, there are 57 locations for Family Search, and one of them is a 20-minute walk from here in Alicante? Now, Family Search also runs Roots Tech, which is the world's largest family history technology event. It's held online and in person in Salt Lake City, Utah. 15,000 attendees, millions of people attending online from 250 countries. Now, I've attended online sessions in history, research, DNA, and AI in past years. And with so many sessions, there might even be a niche topic that interests some of you. Next, we have Ancestry.com, which is very popular in the US. It's the largest for-profit genealogy company in the world. They also have billions of records and millions of users, and they run Ancestry DNA, which is the world's largest DNA company. And let's not forget MyHeritage, started about 20 years ago in Israel. They have AI features like Deep Nostalgia and AI Time Machine, and are very popular in Europe with European ancestry records. So all of these services, they allow you to create and manage an online version of your family tree. You could even export your data from one place and import it into another place. So how is that possible? That's where GEDCOM comes in. And what is GEDCOM? Well, GEDCOM, the name, originally comes from genealogical data communication. But we can basically think of GEDCOM as a file format. The purpose of GEDCOM was to allow family history data to be exported or imported and shared between genealogy software programs. So here's an example from President John F. Kennedy's family tree, sort of a sample tree. GEDCOM looks a little bit kind of like YAML. Unlike YAML, though, it's meant for machine-to-machine transfer, so there's no indentation and no comments. It also includes hierarchical data with numbers where each number represents indentation levels. This is what it would look like if it were indented. So we have the number surrounded by the @ signs, which is a unique ID for this file. It's like a database primary key for an individual. You see standard tags in all caps, INDI, name, birth. These are standard part of the spec. Most tags are 3 to 4 characters. They could be longer. The name tag, you can see that there are slashes around the surname. And that's how we know which of these names is the surname without having any awareness of cultural context or naming conventions. A birth event here can have a date and a place that describes it. Like a CSV, it's comma delimited, and you can see sort of column headers under the form tag there. We can have important life and career events, like Kennedy's military service and senator time and presidency of the United States. Here's a very historic event as GEDCOM data. This was Kennedy's assassination, President Kennedy's assassination, and his burial in Arlington National Cemetery. So if we took Courtney's map of DC, we could actually go visit the grave with the geo-coordinates right there. Now, for individuals, we have 2 tags, FAMS and FAMC, and these are family IDs, and depending on whether the person is the spouse or the child of the family, and those families will be included in the file as well, along with a marriage event. Okay, GEDCOM files, they have a head tag with meta information and a trailer tag. They can also be used to, they can also be extended with custom tags that are prefaced with an underscore, and that allows software to create new features which creates sort of a dialect of GEDCOM. For example, here you have unique IDs and family search IDs to help dedupe those individuals. When Family Search first released GEDCOM, you have to understand that that was 1984, and people were used to printing out their data from one software and going to another software program and typing it all back in again. So this was obviously a huge improvement. But over the next 40 years, not a lot of releases here, right? And some of them are really just cleanups, no new features. In fact, the latest version a few years ago was released at Roots Tech in 2021, but it's still slow to catch on. Thanks. One of the original goals of GEDCOM was interoperability, but for many reasons, it just hasn't lived up to that promise. But at least we have some shared language. Now, the more I work with my own family history data, the more I see it evolve multidimensionally. It grows vertically as I go back in time, adding distant ancestors. It grows horizontally as I discover many distant cousins. The tree also expands geographically as people migrate and change locations. And my research about existing family members increases the fidelity of the data over and over again. The data also grows temporally. New families are formed through marriages and partnerships. Baby nodes are born all the time. And even when a relative dies, they never leave the GEDCOM file. Now, out of all the standard genealogy charts, I'm a big fan of this one. The central focus is on a root person from the tree, surrounded by rings representing parents, grandparents, and ancestors. Each wedge is subdivided from ring to ring, showing the binary split with each generation. You can even invert the chart to show a person's descendants instead of ancestors, and in that case, the wedges are divided by those children. There are 2 things I love about the chart. The first is the perfect symmetry of those inner rings. The second is the asymmetry of the outer rings. That negative space tells me that data is missing and I need to go find it. Now, the data is meaningful to me because it contains people I know and love, and an unbroken chain over centuries of people that they knew and loved. So I was inspired to create a project where I could sort of marry my passion for family search with my love for creative coding. So I set out to create digital artwork from family data that's abstract, personal, and legible. Now, my first step was to plan a very high-level POC, proof of concept. I had GEDCOM file, and I needed to convert it to JSON. And in a React app, I want to import that file, visualize the data, and export it as an image. So I got my POC working with a minimal GEDCOM parser and React. I used P5.js to render nodes and edges on the canvas. And then I exported a PNG of the art. Voila. Now I just need to iterate a bit, right? So for an MVP, though, we have a bigger challenge. And that is how to translate GEDCOM data for the canvas. GEDCOM has individuals and relationships and names and dates and places. A canvas deals with things like lines, shapes, positions, layers, opacity, and colors. So how do we map data to visual attributes? That would be the magic. So I created a CLI to basically handle some of these jobs. It has two jobs. The first one is to convert the GEDCOM data or parse it to JSON. So here we parse some GEDCOM tags. We can add more tags and support future GEDCOM versions, whatever. And then the second job here is to offload data calculations so that the UI won't stress out in the future. To support visualization, we can even infer some of the missing data, maybe, a little bit creative license, like locations, maybe taking cues from relatives or pattern matching. We can also calculate graph metrics, things like assigning individuals a generation number, or counting connections between family members, ancestors, descendants. We could also analyze patterns of the data, like lifespan and countries, family sizes, marriage ages. So this metadata is all going to get joined along with the GEDCOM JSON, and we can even build adjacency maps for quick O of 1 lookups, like an individual's siblings, or their parents, or their children. Another thing is I kind of want to strip out the PII, or the private information. Maybe we'll even send it to an LLM at some point, so it would be nice to have a version that's sort of sanitized. So in the end, the CLI produces basically a file of the full JSON with metadata, local only, git ignored, an LLM-ready JSON with PII removed, and this is all very fast and can handle multiple GEDCOM files and produce a manifest with a CLI version number and a build number. Now, in the app, we can add a transformer pipeline. So its job will be to take the family data and calculated metadata from the JSON and convert it to visual metadata. So in the app, we'll have some transformers, which are modular building blocks for translating the family data to visual attributes. They're like pure functions or reducers, but asynchronous. And they receive the previous transformer's output and also some pipeline context, and they produce new output. And they're designed to be composable within a pipeline. They can affect things like layout, nodes, edges, or maybe a mix, maybe something more data-centric. They're user configurable based on a UI. And users can even choose from preset combinations of attributes with semantic or artistic meaning. For example, there are also nodes and edges, and nodes and edges are going to be represented as arrays of layer objects. Nodes can have a root X and Y position, and layers can have their own relative positions and attributes like color, opacity, and shape objects. Now, the pipeline configuration includes arrays of transformers in a particular sequence. Users can add and remove transformers, and they can be enabled or disabled. Since transformers create many layers, we're going to need some sort of a layer merging strategy as well. And when it's applied at the pipeline level, then we'll use some layer budgeting. All right. Now, the last bit of this is the painter. And the painter takes the final visual metadata from the pipeline and calls P5 API methods to draw art on the canvas. It can take stacks of node and edge layers and apply blend modes. Remember, visual metadata is declarative. The painter can translate those to invocations of these API methods and manage hit detection. That's a lot of theory. Maybe we should take a look and see what that looks like. OK. And let's see. OK. Welcome to a Gen Art project. When you first come in here, the first thing you probably notice is that it no longer looks like the proof of concept. Thank goodness. Right now, we've auto-loaded 2 family JSON files, one for my own family and one for the Kennedy family that we saw earlier. They're located up here. You could choose between them. You could even load more. We're not going to do that now. The first thing you're invited to do is to choose what we call a primary individual. That's similar to the root individual that you saw in the fan chart. So I can come here and just type John Fitzgerald Kennedy. It really doesn't matter whether it's the 8th generation or the 9th generation one for our purposes. All right. Then we can go here and configure the transformer pipeline. Now, transformer pipeline has a selection of transformers here. They're sort of separated by their type. We have layout transformers, node transformers, edge transformers. I'm going to go ahead and just select a fan chart layout to start with. Let's go here and take a glass shard node transformer. Maybe we'll pick an edge like the edge ribbons. OK. Now, right away, I've already picked an individual, so I can come up here and I hit run. And so you see that we've got a combination of the sequence of transformers producing something on the canvas. I can go in here. I can click something like full circle. But now I actually have to hit Command-Enter to run it again. Or maybe what I can do is just click auto, and we'll just auto run from now on. So if I were to go down here, we can change the number of generations that are represented. And that's going to give us a different kind of look here. We can go into the glass shard transformer, and we can look at some different styles. For example, here. And then also, you'll notice something else about the pipeline. We have panels for input. This is where we have the full data, the visual metadata, all the individuals, all the edges, et cetera. We have an output panel where you can see the same thing coming out of the pipeline. You can also do a diff of those two if you want to kind of debug and see what you're looking at from a data perspective. And the configuration of the entire pipeline itself is here, and you can copy it, and we can store that as a JSON file as well. So you could rehydrate the pipeline. Now, I'm going to show some other features. Oh, another thing here, you could hide the nodes here. You could hide the edges. I'm actually going to make these a little bit bigger. I'll just make these large here, so they're a little more obvious. And we also have some other features where you could change to light mode. You could apply gradient backgrounds, stuff like that. And we have something called interactive mode. Now, interactive mode basically allows you to hover over one of these folks and then see who it is. And you can actually set them as the primary individual, thereby navigating through the tree dynamically like this. Now, eventually, you're going to get to a dead end because this person has no more ancestors, right? But we have sort of a way to browse suggested people in the tree based on the number of ancestors or the number of descendants that they have. And you can see that it produces some different patterns here based on who that is. OK. Now, I'm going to look for somebody in particular. And that is a Mary Sophia Lanigan. OK, now, right now we only see her on the screen, though, right? No family members. And that's because she has no ancestors. And we're in sort of an ancestor fan chart mode. But she has 60 descendants. So if we come over here, and we go into our fan chart, and we go into custom, we can actually change the fan chart to show descendants. And right now, she has a string of descendants, but not a lot of family members. But as soon as you go to a certain generation, she's got a lot of family members. And another thing that we can do here is we don't need to constrain ourselves to the frame. We can kind of burst out of the frame. We could even go frameless, and we can look at some art like that. And then once we do that, we can even further explore, seeing what kind of other patterns could we get here from other people. OK. Now, enough the Kennedys. I want to show another few examples from my own family tree. But before I do that, I'm going to come up here and turn on this privacy mode. That way, you don't have to see all the details of my family. A lot of the members are still alive, so it's best to not do that. And one other thing I also forgot to mention is that at any time, we can take snapshots of this. We can even turn on auto snapshots, and every time you run the pipeline, every time you make any kind of change here, we would just basically regenerate a snapshot. OK. So now I'm going to come over here. I'm going to switch to this. I'm going to reset the entire pipeline. We're going to start fresh, and we're going to look at some other layouts. And then this is grid layout, so that's simple enough. And this is probably the easiest way to see everybody in the tree all at once. And then we can still take a look at the glass shard node. All right, and so you see here, this is sort of very colorful. But we also have different versions of the grid layout. For example, this one here is family clusters. So we've got family members clustered together, which creates some negative space in between, which is also a nice effect. And then once we do that, we can actually navigate through and look at some of these other styles. I actually really like this one, sort of a black and white with a little splash of color. OK. Another layout that I wanted to show you is, and I'll just reset this, is a DNA helix. So as that sounds, this actually represents families. OK? And the families it represents is we have one edge of the helix, which is one partner, and then the other edge is the other partner. The lines between them are their union, and the dots, which very faint here, the dots are the children. And we can choose different types of configurations of that, make that a little smaller. And one fun thing is that if you were to modify the date range of the unions that you're talking about, you can get a more sparsely looking helix, which has its own design aesthetic. If we were to add to it a node transformer, then we can add this genetic inheritance transformer. And what that is basically family members in the same family have very similar visual attributes, except there's a mutation rate that changes from generation to generation. So siblings are basically the same and similar to their parents. All right. So one more example is we're going to go back to the fan chart, because it is my favorite. And I'm going to just move that up here, or take out the DNA helix. OK. Now, for this one, I'm actually going to go over here and choose somebody in my immediate family. Oh, OK. Let's turn that off for a second. And we're going to look at this. First, I'm going to do the full circle here. OK. So, and close that one. All right. So this is the country colors. Country colors basically are like flag colors, and they're taken from the birth country. A lot of that we inferred, although some of it we have. And you can see that depending on the preset, we have more literal matches of those country colors. So for example, this one is authentic. And you can actually see, we have Germany and Belgium and Israel and Poland and Russia and Vietnam and all these countries. This pioneer mode emphasizes people who actually changed country from their family, from their parents. And we have bold pioneers. And I like a combination of something like authentic country colors, maybe with a little bit more bold emphasis. Okay? Now, we don't have any edges here, so we need to add edges. And for the purposes of the demo, I think I'm just going to throw the whole kitchen sink in here. So we've got a lot of different options. We have edge ribbons. We can choose different colors. And again, if you hide these, you can sort of see what they look like. All right. So let me just move that up here. OK. Now, before we go, I'm going to go into custom here, and I'm going to crank up the generations. We're going to make things a little bit more open in the middle. Let's throw on a spiral twist. Oops. OK, sorry. Throw on a spiral twist. Let's add back the genetic inheritance. So now we have a mix of the country colors and genetic inheritance. And then let's look at our layer strategies. We have merge, wrap, shuffle. And this is my close family and our ancestors right here. I'm going to come up here and take a selfie snapshot. No, I guess it's already on auto mode, so it's been doing it the whole time. Anyway, that's what I wanted to show you about this app. Thank you. There's more. That's just the demo. OK, 1 second. Let me get back to. Hold on a second. OK. OK, so. All right. Very good with time. We should talk about state management, though. Now, I was able to iterate very quickly with some of these features using the assistance of AI, but it did not come without a price. Now, my components were riddled with use states and use effects and a lot of multi-level prop drilling. Maybe you've also experienced that. And it made adding new features increasingly difficult. So it was really a problem. So what I did is I abstracted a lot of these things to custom React context for managing things like the data set in the pipeline. And I also tried to use better patterns for React state management. For example, still using useState, but with things like type unions for mutually exclusive string values instead of many Booleans conflicting. Also, using things like useReducerHook with event-based state changes. Now, Aurora Scharf spoke this morning, and she actually wrote a blog post on certificates.dev that talks a lot about these sort of easy wins for React state management. I even used the lightweight XState store, which was really great at getting state out of the way while you can sort of rely on it being predictable. But after trying so hard to, you might not need a state machine, eventually I just looked at the app and the complexity, and I was like, Kevin, just use XState. It's free. And besides, Eric Rasmussen gave me the green light to use it. So I created an actor system. So now there's an app actor, which is the only React context that's wired up to the UI. And that actor can invoke other actors which communicate with each other. So for example, the dataset actor to manage the GEDCOM data, the loading, the switching, the changing the primary individual. A pipeline actor for managing the pipeline configuration, the transformers. And then that would actually go into an execution state and call another actor, the pipeline execution actor. That handles the sequential asynchronous steps for calling transformers and merging the visual metadata. And of course, the UI actor. I think the single biggest win from using something like the actor system here was the ability to allow users to auto-run the pipeline whenever they made changes, anywhere in the app, right? So basically, the UI just sends an event to a state machine, one of these appropriate actors, and data is stored, and the events are forwarded to the pipeline execution machine. It's declarative, it's easy to maintain and extend, and it all just worked. One more thing, though. Since the pipeline execution machine is XState and TypeScript, and this pipeline can also run in a headless environment, then the CLI can auto-generate batches of images based on random combinations of the pipeline configuration. This can be used to output SVG or PNG. I would say so far the results are not as good as in the app, but producing batches of hundreds of images is super fast and cheap. And in the digital world, sometimes quality comes from quantity. We can debate it over beers. Here's just a few resources that I've been checking out lately about GEDCOM, family history, creative coding, blogs, podcasts. There's actually a new conference I wanted to mention, Upscale Conference in Malaga, which is about creative AI, like art, images, video. And I was introduced to a software called Comfy UI in a workshop by Joshua Davis, an artist I've followed for many years. Comfy UI is a node-based visual editor for AI image processing. And some of the ideas from that software inspired the project that you saw today. We covered a lot of stuff here. The biggest online genealogy platforms and the Roots Tech Conference. We looked at GEDCOM with examples. We walked through the stages and concept of a POC and MVP of a data art project using GEDCOM, React.js, and P5. And we dug into a transformer pipeline run by state machines for on-screen and headless image generation. Whew. We work in an industry where new things are happening all the time. And I think that's even more so now with AI, right? But to me, that's always been super fun and exciting and interesting. But it can also be a little bit stressful at times. I think as web developers, we can all relate to that. So it can be nice to sometimes take a step back and work with technologies that don't always move as quickly as everything else around us. So whether that's exploring GEDCOM, or building state machines, or collecting family data year after year, finding a project that you can visit over and over again can have a positive grounding effect on your work and on your well-being. So always remember that you are the primary individual here. So use the web development skills you have and that you're getting at this conference, unlock your creative potential, and go create something that's deeply personal and every bit as special as you are. Muchas gracias, React Alicante. Thank you.